Okay, here we want to look at indeterminate form. Okay, and what we do when we use direct substitution, trying to find the limits, and we get indeterminate form. Remember, indeterminate form is when we have either 0 over 0 or infinity over infinity. Now, in these two cases, we're going to look at 0 over 0. Now, one thing that we have to remember, 0 over a number, the result is 0. But 0 over 0 is indeterminate. So let's look at it. So first, we have the limit of x squared minus 3x minus 28 divided by x squared minus 9x plus 14 as the limit approaches 7. So now if we were to plug a 7 in using direct substitution, that would be 7 squared 49 minus 21 minus 28, which would give us 0. And in the denominator, we would get 49 minus 63, which is negative 14, plus 14, which also gives us 0. This means that this is what? Indeterminate form. This is indeterminate form. So now, what do we do in this case? Because, like we said, if we had 0 over a number such as 0 over 5 or 0 over 8 or 0 over 12, the answer would just be 0, and we could solve it. But here we have 0 over 0, which is indeterminate form. So this is how we break this type of problem down. We divide the top and bottom, and we just factor using our old algebra. This would give us x minus 7 times x plus 4. Okay, and x squared minus 9x plus 14, this would give us x minus 7 and x minus 2. Okay, so we go through, of course, as we all know, the x minus 7s are going to cancel, and now we can use direct substitution. 7 plus 4 gives us 11. And 7 minus 2 gives us 5. So the quickest mistake we make sometimes is we just put 0 over 0 and then we move on. But that's not the case. Indeterminate forms, which basically means what it says, we cannot determine from this point. All right. So now let's try another one. We also want to look at, let's look at this type of problem. Now, let's look at this one. We have the limit of the square root of x plus 1 minus 2 divided by x minus 3. All this is x approaches 3, of course. So if we were to use direct substitution and plug 3 directly in, we would get the square root of 3 plus 1, which is the square root of 4. Square root of 4 is 2. 2 minus 2 would give us 0. And 3 minus 3 would give us 0. So once again, this is indeterminate form, which simply means at this point, we cannot solve it. But like I always say, indeterminate form is not a solution. It's a condition. It tells us to keep moving forward. Now, this problem is a little different, so we can't just factor it. But what we can do is rationalize the numerator and the denominator. So let's do that here. Now, if we remember, we have to multiply top and bottom here. Now, this is really going to go back into things that we have not seen in quite some times. But as always, anytime we're doing calculus, it's going to require us to reach far back into our algebra rules. So now here, we still want to use the FOIL method. The first, outer, inner, last. So the square root of x plus 1 times the square root of x plus 1 is simply what? X plus 1. Let's look at our outside terms. The square root of x plus 1 times 2 gives us 2 times the square root of x plus 1. Let's look at our inside terms. That's negative 2 times the square root of x plus 1. And then let's look at our last terms, which simply gives us a minus 4. Now, when we look at this last one, we're going to end up getting x minus 3 times the square root of x plus 1 plus 2. Let's keep moving, and then we're going to simplify. So the first thing I would do, I would cross this out and simplify. So we will end up having x plus 1 minus 4, which gives us x minus 3. Then over x minus 3 times the square root of x plus 1 plus 2. And we can slowly see this problem working itself out and breaking itself down. We just want to stay sound algebraically. So now, what's going to happen here? These are going to cancel. So we have 1 over x squared plus 1 plus 2. And now, I'm going to move this to the bottom. And now let's plug the 3 in. That's going to be 1. The square root of 3 plus 1 is the square root of 4, which is 2. And 2 plus 2 gives us 4. So our limit is 1/4. So we do not want to stop when we see indeterminate form. Down the road, we'll learn how to use L'Hopital's rule, which is another method for it. It works well in other cases, all right? But for now, we're using these terms. These methods.